All right, I'm back. I think I need to speak just a little bit louder to make sure everything that you can hear it. I'm on the second page. I know it seemed like it's taken a long time to get here, but I want to mention I'm going to be sending you an email. Ruby Ramos um, was a student of mine last semester. She's going to be in the Student Success Center working, and her hours Monday through Wednesday 12 to 4, and Thursdays 12 to 3. So we'll be meeting on Thursdays, so you can see her Monday through Wednesday. And believe you me, you're going to need the help. So I'll send that on by email. Let's talk about the periodic table and symbols, groups, periods. Let's start with symbols. I wrote one, whoops, pen. Here we go. I wrote a symbol earlier, and that was sodium. Here it is. And let's look at another one, aluminum, and of course carbon. Notice that all of them start with a capital letter, and if there is a second letter, it is in lowercase, or I guess the other word for capital is uppercase, and then the second letter is lowercase. So here, hydrogen would go here, and you could be looking on your periodic table as you go along. Lithium is here. By no means you don't need to memorize where these are, because you're always going to have a periodic table to use, but it's kind of nice to get to know these. So again, uppercase and lowercase, and something like aluminum, it is incorrect to write that. So this is incorrect, right? The correct way is AL and a small l, and that is aluminum. All right, so that's enough about symbol. Let's talk about groups. Group is the column. Some of them have names, but all of them have numbers. Let's look at the very first group, and that's group 1A. We're going to be using the nomenclature or symbolism with the 1A. You may notice your periodic table has a different numbering system across the top as well, more than one numbering system. We're going to use the 1A, 2A, 3A. So this is group 1A, and this one actually has a name. We'll talk about it in a little bit. And group 2A, so again, groups are columns, they go down. This is group 8. It's really important because there are trends in these groups. For example, all the elements in group 8A tend to have similar characteristics. All right, let's look at a period. Now, period goes across. And notice I've numbered these on the left. So period 1, period 2, period 3, etc. So all across here, there are only two elements in period 1, hydrogen and helium. Okay. In period 2, we have lithium, and it goes all across here to neon. Okay. So period runs across. Okay. I guess that's it for this page. Let's move on to the next page. Let's clear this because I actually want to talk about something else. And now that clear comes in handy because I want to use the periodic table for another reason. Let me scroll down a little bit. When I scroll down here on this same page, I'm going to talk about the periodic table in a different classification. The periodic table consists mostly of metals. Now I'd like you to do this portion on your own. Use table 2.4 and fill the information in. For example, one of the important things you'll notice about metals, they're mostly solids. Okay? For example, sodium is a solid, iron is a solid. You know these to be solids. Exception, mercury is an exception, a popular exception. So most of them are solids. And so use this table fairly easy. I'm going to go back up to the periodic table and and point out where you can find these. Did I pass it? Yeah, I did. There we go. All right. Notice that there is a line, a heavy black line, and I'm going to make sure it's clear by putting this in red. I tend to call it a step. So when you hear me talking about this step, this is what I'm talking about. That step differentiates or separates, is a better word, metals from non-metals. So on this side of the periodic table, we have metals. All metals, all here. Metals, metals, metals. So most of the periodic table are metals. Now, hydrogen is here. I want to be very clear that I'll be talking about hydrogen and some differences about hydrogen. The fact that it's really not a metal. It is actually a non-metal. It belongs really on the other side, but we'll talk about exactly why it is in group 1 on the last page of this chapter. All right, so there it is for metals. Let's change this color. So non-metals are on the right side of the periodic table. So here, non-metals. Metals. Not sure if that's clear enough. And then there's another category, and those are the elements just right between the metals and the non-metals, and these are called metalloids. Hopefully I'm shading in the correct one, but do check your periodic table. I believe these are they kind of flank the line. Now the metalloids are interested, this is what we're talking about here. They are in between metals and non-metals in terms of their properties. For example, from a physical perspective, they behave more like metals, but from a chemical perspective, they behave more like, hey Bob, you confused me. I'm still recording, by the way, but my students need to know that's how I am. Right, so let me say that again. They're more like metals in terms of their physical properties, so they look more like metals. They are as hard, tend to be as hard as metals, but they behave more like non-metals in their chemistry. So if you do a reaction, they'll behave more like non-metals. All right, so go ahead and fill this table. Use your book to fill that table out. All right. Okay. On the next page, go to your next page, and I'll be talking again about the periodic table with respect to representative elements. Representative elements, alkaline metals, alkaline earth metals, transition metals, and so on. I've filled in quite a bit for you, so representative elements are found group 1A to 8A. So these are the A's. Transition metals are the B's. And then some of the A's have special names. So 1A, alkaline metals, alkaline earth metals, halogens, and noble gases. Let's go back up for the examples. And again, I'm depending on you to go through your text and fill some of this out. This is the nice thing with internet class. You better read the book, or else you are in trouble. Right, Ruby?
Yes.
Ruby's still here with me. So, not completely crazy. So, let's see. Group 1A, so sodium, lithium. Oh, I need the pen. So, lithium, sodium. What's next? Potassium. After potassium is what, Ruby? I forgot. Rubidium. Okay, so these are good examples. Sodium, of course, very, very popular element. We find that in salt, very important element in our bodies. So these are your alkali metals. By the way, alkali simply means that it's a base. And remember, it makes basic solutions, and a base is an opposite from an acid. We'll talk about that in chapter 7. So these here, your alkali metals. Group 2A also has a name. These are your alkaline earth metals. So again, follow on the next page. ARTH, earth metals. Alright, so these. And then your magnesium comes in here. I think magnesium is here. Calcium is here. I think barium is here. And so on and so forth. Strontium is next?
No, it's BA is strontium, like on the SR, and then the BA.
Okay, strontium is next. Okay, so these are your alkaline earth metals. They are very abundant in the earth's crust. By the way, the first one, let me just skip back to alkaline metals quickly. These are so very reactive. Also, the alkaline earth metals, they are so reactive that you won't find them pure in the earth. They're always reacting with something else. Like you'll find sodium with chlorine a lot, sodium chloride, and so on. Again, please remember, hydrogen is not a metal. We'll explain that in a little bit. Alright, so we've done alkaline metals, alkaline earth metals. Let's skip over transition metals for a little bit. It's belong to the B group. Okay, so these are our transition metals. And let's go over to group 7. These don't have names. We're going to talk about the ones with names. So these are your halogens. Popular halogen is chlorine, Cl. Chlorine, fluorine is up here, of course. And bromine is here, Br. And some more. Those are the most popular ones. Of course, chlorine, a big component of our bleaching system. It's a good oxidizing agent, so it gets rid of color and all kind of things quickly, bacteria as well. And then the last one with a name, noble gases. Noble or inert gases. You'll see both words. Right? These are important in that they do not like to react with anything. That is what the word inert means. They just like to be by themselves. A very popular one would be helium. And what do we do in helium, Ruby?
Make balloons.
Make balloons, and sometimes have a little bit of fun with it as well. So if this was a reactive gas, we couldn't put it in balloons. We couldn't hang it around children. It could, it was reactive like hydrogen, then it could explode. So it is not reactive. This is why it's called inert. And all these gases are very similar in that respect. Am I recording?
I thought so. I pressed it.
Okay, hang on. Hopefully I'm recording.
I need to switch back to PC.
Oh.